two that we're doing today, we're basically talking about how to evaluate scientific notation, powers, roots with our graphing calculators. So it's mostly calculator instruction. So some of the problems will say that we want to use a calculator to simplify a mess. First thing we want to do is this button that I've circled over on the right, right up above the division sign. If we do control divide, it will give us a fraction bar and let us write as long of a thing up on the top as we want to, and the same thing for the denominator without having to worry about parentheses. I also want you to notice this 10 to the x button, or you could also do the EE, but I like 10 to the x better. So to do this one, so write down the problem on your paper, and then we're going to type that into the calculator, and I'm going to pop my calculator screen up here and do this with you. So I need to be sure I am either in the scratch pad or I am on a calculator page. And I am going to do the control and then divide. And so now I've got a fraction bar with a dotted box above and below. Up above, I want 0.000. So 1, 2, 3 zeros after the decimal, except it did not take my decimal there, so I'll try again. 0.123, and then a 42. And then times, so obviously multiply. And then all I need to do, since this is 10 to something, is push the 10 to the button. I don't even have to do 10 caret, which is my other choice. And then I need to put the negative 17 in there. Be sure you use the negative sign, not the subtraction sign. Negative 17. Then all I need to do is to use my down cursor. So I get in the box that's down at the bottom. And this one was 568,425 times 10 to the fifth. And the other thing you could do, if this isn't a 10 to the something, you could do times, and you could actually type the 10, and then this caret button, it looks like a little arrow pointing up, that always means to the power of 5. That's a little more typing when it's a 10, if you use the caret button, a little bit less if you do the 10 to the x button. And then all you have to do is push enter and say that that answer is all of this. But you've got to remember to look carefully. Always check out on the right when you're doing these. We do not use E, we use 10 to the for scientific notation. But this means this big old long messy decimal times 10 to the minus 32. So we're going to write it as 10 to the minus 32 and with an x before the 10. And we're going to round the first part so it has 3 decimal places. So 7.389. So if I go back to my paper and write that down, I can say that is approximately 7.389. Use an x for the scientific notation, 10, not an E, and then the minus 32. Okay, another type that we need to be able to evaluate is taking a weird root. This isn't a square root, it isn't a cubed root. It's a 4.2th root, whatever that may mean. So all we want to do now is, if you look below the equal sign button, so kind of to the left of the 4, there's a caret symbol, 4 to the power of, and up above that is what we want, so it's going to be a control on that. So what we would do with our calculators is we would do control, and then we would do that caret button, and then we again have 2 boxes to fill in. So we're going to put a 4.2 on the outside, and then we're going to use our cursor to move to the one that's inside. Type in 156, enter, and we should have no scientific notation out here on the right, but we'll round this to 3.328 and write that down. Anybody home or in the classroom with a question on that? At home, you can hit the raise hand button, you can type something in chat, you can unmute to let me know what we need on that. So we said that one was approximately 3.328. We can also do weird powers, and I kind of talked about this on the last one. This isn't 10 to the something, so I can't use that 10 to the x button. So what I'm going to do is I'm going to use this little caret button, and I can also, for parentheses, use this. Anytime you're in doubt whether you need parentheses or not, use those to be able to type it. So I am going to go back to my calculator, and I'm going to do my left parentheses, and it automatically on the Inspire types both of them. So I'm then going to do 1.86 on the inside, move to the outside, that little caret button beside x squared, 2d, and it's a negative, so I use the negative button under the 3, 4.86. Make sure that what shows up on my screen looks like what I'm trying to evaluate. And enter, no scientific notation, so I just need to copy this down to 3 decimal places, 0.049. And write that down. Thumbs up at home and here. Are we good with those? Okay, some of them will have things like this. Some of them may even say, estimate first. You can just totally skip estimate. This just means punch it in on the calculator. Sometimes they'll have the big old long fraction bar, sometimes they won't. So we just need to enter this. So you guys go ahead and give that a try. Everybody at home and here, you're just going to type in the 0.0042 times 10 to the minus 17. You can use the 10 to the button. And then you can just do times again. You don't even need the parentheses on this one because it's all multiplication. 568, 425 times 10 to the 5th. People at home, type in chat what your final answer is. Check whether it needs scientific notation or not. Wait to hit enter for me at home. Molly, what did you get? If people at home hit enter, Molly, what did you get?
I got 2.387 times 10 to the negative 10.
In the classroom. Anybody else get that? Let me see what we have in the chat. People at home hit enter. So you got the same thing. So it looks like we are in good shape. I won't take time to go through that. So many of you were already doing some of these last year and earlier this year, so some of that may not have even been new to some of you. I think this next part is going to be new to everybody. We have had plenty of systems that we have solved on the graphing calculator, and we've done the menu analyze graph intersection. But we always had to write these y equals before we could enter them as a function, because the calculator required that. Today I'm going to teach you how to do it without having to change it to y equals. You can enter it just like that, and then we'll do the very same thing. So copy these 2 equations down on your paper, because when we're looking at my calculator screen, it's going to be harder to see those. Maybe I can minimize this a little bit. I can't reach that high. Okay, I can sort of see it there. Okay, we are going to need to be on a graphing page, so either in your scratch pad, or if you're in a document, do a new page with this. So I'm going to do a new page on mine, and I'm going to maybe, I've got it minimized too much to be able to do what I want there. There we go, add graphs. Okay, now instead of this f of x equals, because that means you've got to enter it as y equals. I'm going to hit the menu button. It's always our best friend. I do want to enter something for it to graph, so I'm going to pick choice 3. Up to now, we've been doing functions. Today, we want to pick choice 2, relation. Once we have done that, all we have to do is to type it just like what we saw. So I need to type in. Now, 2/3, do not round it to 0.667. So I'm going to do parentheses, 2 divided by 3 parentheses, or I could have done that control divided to get a fraction bar in there. Hopefully that's showing up. Okay, and then that was times x. So then I need to hit my x to get the 2/3 x. Then I need plus 2/5, and I'll do this fraction the other way. So plus, and then the control divided by will give me that fraction template. And I can do 2 on the numerator, down for 5 in the denominator. Must hit the little arrow, so because I do not want the y in the denominator. And then I've got my y. Now you have an equal button over right underneath the control button, so you hit that, and 28. And then you hit enter, and right now I don't see it on my graph because I need to change the scale on my graph in a little bit. So let me make that a little bit bigger so we can see what we entered. You could have done 0.4 instead of a 2/5, because 2/5 and 4/10 are exactly the same, no rounding, if that had been easier. Okay, when you're ready to do the next one, you hit the tab button, hopefully. Oh, I got that on the wrong thing. And now it should say relation 2 in terms of xy. And now we're going to enter the second equation. And this time we have decimals. Use the negative button, 0.05. And then minus 0.2y. And equals, and that was negative 5.5. Negative 5.5. And enter. So everybody have the 2 relations entered there. Okay, I'm going to go back and look at these and talk about them again. So I hit tab just so I can see what I typed in. Decimal one, double check that it looked like what your equation needed to be. And again, look at the one with the fractions. If either x or y is in the denominator, you have to go back and fix that. It's not going to be a line if you put the x or the y in the denominator by accident. Go back and erase it, and then tab so that you're doing it to the right of the fractions. Okay, now since I can't actually see that, I need to change the dimensions on my graph. So I'm going to do menu. And I want window zoom. I think I'm zoomed in too close to see it. I'm going to start with zoom fit and see what happens. Ah, now I can see the lines. I don't see the intersection yet like I'm used to, but I think it's got to be off to the right, the way those lines are tilted. So I can menu, and let's see, I want to change the zoom again. I need to zoom out a little bit more. And it tells me this. I'm going to maybe try the center kind of over here and see what happens. I'm getting closer. I've still got that little magnifying glass, so I'm going to type again to change this in there. Now I can see where they cross. So everybody good with that? And now it's just like you did before. Menu, analyze graph. We want the intersection. Go to the left and the right of the point, and it tells us the coordinates. I can't read them real well, so I grab them and move them 30, 20 for that intersection. Does that make sense to everybody? If we ask you for a graph, you just kind of do the best that you could to sketch something like that, since we don't have it in y equals mx plus b form. I'm not going to expect that. I think most of them we just say what is the intersection. No, it does say sketch a graph on that. So it was 30, 20. And one of them was almost straight but not quite, and then the other one was steeper, and they did cross in the first quadrant, and so that's what you'd be sketching. Easy enough, right? Anybody with a question on that? And I think that ends that ends the first lesson. So everybody at home and in class, just stand up right where you are and stretch for a minute before we do the second lesson. And I'll get it loaded while you guys do that. Come on, stand up. Get the legs moving a little bit at home. Stand up, stretch for just a second here. If we've got to do 2 lessons back to back, let's at least give ourselves a little bit of a break there. As my computer's being weird with the size of all of these screens today. There we are. Okay, I think we can see that now. All right, so gas law problems. We already know the gas law. And so this is just building on what we've already learned, but primarily doing word problems for gas law type problems. So if we start off, I haven't on the next slide or not. Yeah, what is the gas law formula? Who remembers? Sarah, you remember what the gas law formula is? It's got those P's and T's and V's in it. You remember how that works? Yes? Perfect, thank you so much. So gas law formula is if we take the P's times the V's and divide by T, we always get the same number. So P1 V1 over T1 equals P2 V2 over T2. That is what we are going to be doing. So we will have problems that look like this. So a lot to read through there. Always, I want you to first write a formula isolating what you try to find. So always first get a formula isolating what you need to find. So in this case, they're going to ask us to find the second temperature. So we're going to take that, and one of the easiest ways to do it is to first do the cross product. P1 V1 T2 equals P2 V2 T1. Then, since I want to isolate T2, put a circle around it if that helps you see what you need to do. Divide both sides by that, so T2 is P2 V2 T1 over P1 V1. Be sure you double check your subscripts that you get those right, because that's the trick to it. Write it neatly, not where you've scribbled stuff out. One line that's nice and neat. Now we're going to substitute in. We're going to start reading what we have here. So initial pressure is 40 times 10 to the 4th. So we're going to have to combine with what we had with the graphing calculator skills. P1 is in my denominator. So 40 times 10 to the 4th. Okay, initial volume. So the next thing is volume. This is V1. V1 needs to be in the denominator. 0.123 0.00003 times 10 to the minus 6. Okay, initial temperature, that needs to go in my numerator as 700 times 10 to the 4th. Then I want final temperature, that's my T2 that I've isolated. Final pressure, so that is P2 is 0.0004 times 10 to the 15th. And final volume, so V2 is 0.015 times 10 to the minus 14th. Must write that down showing the substitutions. Must always write down how do you enter it on the calculator. This is how you're going to enter it on the calculator. So you guys all do that. do that control fraction bar, and then type all of these things in. You can use that 10 to the button. Everybody at home, type it in on your calculators. And when you guys at home have it, please type it in to the chat, but wait a moment to hit enter. Okay, at home, please hit enter. I'm looking pretty good at home. And let's see, Connor, what'd you get? 35,000. Check your decimals. Somebody else, what did you get? Lila, what'd you get? Okay. What'd you get, Kara?
I got 3.5 times 10 to the 22nd.
Okay, we're off on some of our decimals. What'd you get, Molly?
I got 3,500,000.
And that is what we should get on that. So we probably got just some calculator entry errors on there. So 3,500,000 kelvins. So those of you that did not get this, go back and take a look on your big fraction bar. Does it look like this? One of the things I did a few times was like I got down here and I did 40 times, and I did my 10 to the button fourth, and then I forgot to do my cursor to get out of that. And so then my calculator typed in times 0.003 still up here as part of the exponent. That doesn't look like this. So it's like, oops, I had to delete and fix that. So look at yours and see if you can find something where you entered the wrong number, or you had something still in a decimal that didn't belong there. It should be 0.0004 times 10 to the 15th. And then back to the main line of the numerator, 0.015 times 10 to the, be sure you use the negative button, not the subtraction, that will give you an error. Negative 14, back to the main line, 700 times 10 to the 4th. And then make sure your denominator looks just like what you see down there as well. Whoops, did not mean to erase the whole thing, but did everybody find an error that you had in yours if you had one like that? Okay, then let's move on to the next one. Okay, so we're going to use our same formula again. So we've got PV over T, and then get the subscripts all in there. This time we need to find P2, so I'm going to do my cross product. P2, V2, T1 equals P1, V1, T2. I want P2, so I need to keep that and divide by everything else. So P2 is P1, V1, T2 over V2, and I lost my subscript there, so let's see. That was a T1. And a T1 there. Now I'm ready to plug in on that one. We'll plug into work here. Okay, initial values. And they don't tell me which one's which. So pounds per square inch. What is that going to need to be for me? Sophia, pounds per square inch. Is that a pressure, a volume, or a temperature?
I don't know.
Well, volume is usually things like something cubed. So I think volume is going to be this one. It's going to be pressure. So that's P1, and this is V1, and this is T1. So we can put those in. P1 is 0.003 times 10 to the 14th. V1 is 0.007. Don't need times 10 to anything on that one. And T1 is 7,000 K. I'll need the K to put in the calculator. Okay, we want the final volume, so V2 is 3 times 10 squared. And final temperature, that was in the numerator, 0.003 times 10 to the 7th. So I want you guys to all enter that. And at home, type what you get for your final answer. Try to include your units at home. What will the units be for a final pressure? They're going to match the units for the initial pressure. I don't even know. How long does this period go? Till 9. Okay, we're in great shape. Still see a bunch of people typing things in on calculators. So always get yourself in the habit of take a look back at what the calculator says you typed in once you hit enter, and it fixes all the format. Make sure that things are where you want them to be, that it matches what you meant to be typing in there. And most of you at home look like you've stopped typing, so at home go ahead and hit enter for me. We've got a lot of pressure going there, according to people at home. And let's see, somebody here in the classroom who actually has a calculator. Austin, you got a calculator? What'd you get?
30 million pounds per square inch.
Perfect. It is indeed 30 million. Pounds per square inch. Did anybody have a calculator that gave it to you in scientific notation? You could convert it if you wanted to, because this always needs to have one not zero number to the left of the decimal, so it had to be 3 or 3.0 times 10 to the. It's a big number, so I need 10 to a positive exponent, so I'm going to count how many places I move the decimal. 1, 2, 3, 4, 5, 6, 7. And on these, I'd take either the whole thing written out or scientific notation with a decimal round to the 3 decimal places. Any questions on any of this? All right, you guys grab your 2 problem sets, 68 and 69. The rest of our time is work time. We can do some of these together that you have questions on. People at home, I want you to stay logged on so that if we talk about some, you'll know that we're doing that. If you guys at home have questions, type them in chat, unmute and say something, but let's do some work time. And it's going to take me a number of days to kind of get a feel for the block schedule again. But a lot of times I'll kind of try to do one set and then some work time on that. And then the other lesson and some work time on that.